Okay, in this video we are going to use undetermined coefficients again to try to solve a second order linear non-homogeneous differential equation. It's a slightly harder example because instead of having just a polynomial as g of x, just an exponential, or just sine or cosine, we're going to have a product of two of those. So in this case, g of x is going to be x times e to the x. We're going to go through an example and see how it works. So let's take a look at the overall thing that we're doing. So it all comes down to figuring out what to use as kind of your trial solution. So if g of x is just a polynomial, we use a generic polynomial. If it's just an exponential, we use like a times e to the kx. If it's just sine or cosine, we use that kind of more complicated a sine of mx plus b cosine of mx. But in this problem, we're going to run into g of x being a product of two things in that left column. So specifically for us, g of x is going to be x times e to the x. And when you're dealing with that, what you do is you actually just take the two generic things that you would have used and multiply them. So what we're going to use for our trial, so our particular solution, is going to be a generic linear, so ax plus b, and then a generic exponential, because we're dealing with a linear and an exponential. And what we want to do, we'll talk about it a little more in a second, but I'm not going to use c e to the x because c times ax plus b would just be cax plus cb, and then you could just turn that back into two generic constants again, and that's why we're just using ax plus b and then e to the x. All right, let's actually do a problem. So we've got y double prime minus 4y is equal to x e to the x. We do this in pretty much the same way that we would any other problem where we're using undetermined coefficients. So first, what we want to do is we want to solve the complementary equation, which is just the homogeneous version of this differential equation. So we're going to find the characteristic equation, which is a quadratic. We're going to solve the quadratic by factoring in this case. And so that gives us two real distinct roots. And so we know how to write the solution to that. So y sub c for our complementary solution is going to be c sub 1 e to the negative 2x plus c sub 2 e to the 2x. All right, so we want to hold on to all of that. And now we're going to deal with g of x. So we're going to look for our particular solution. So g of x in this case is x e to the x. So for our trial, we have a linear and an exponential. So we're going to actually just multiply a linear and an exponential. So y sub p is going to be our generic linear, ax plus b, and our generic exponential, which in this case we're just using e to the x. We don't use c e to the x because that would introduce another constant we'd have to try to solve for. And it just complicates things because the ax plus b already deals with that potential value of c. So we have our trial, and we need to find the derivative. So this is a product rule situation. So first, and derivative second, plus second, derivative first. Derivative first is just a, so we get a e to the x. This you should definitely factor because it'll make your life a lot easier. So I'm taking out e to the x, and I get ax plus a plus b. All right, now I need to find the second derivative. So the second derivative is again the product rule, so it's going to be first, derivative second is still just a in this case, plus second, derivative first, derivative e to the x is e to the x, so we're done there. And we can factor again. It's always a good idea to factor these. Just makes it really simplifies things going forward. All right, so we have all of these things, and what we're going to do is take the values where our trial, our derivative, our second derivative, and our differential equation, and we're going to move it over to another page and use it. So here's what we know. Now we're going to do our substitutions. So I have y double prime, that's going to go there. I have y, that's going to go there. Y prime actually isn't a part of the differential equation, so I don't need to substitute it. But I did need to find it so that I could find y double prime, so that wasn't like wasted effort. All right, let's do our substitutions. So first we're subbing for y double prime, and then it'll be minus 4, substitute for y, and then this whole thing equals x e to the x. And now what we're going to do is kind of factor and then equate coefficients. That's kind of the typical thing. So factoring, I'm going to look for coefficients of x e to the x. So x e to the x, I see ax e to the x from that first term, and then minus 4a x e to the x. Okay, so overall that's minus 3a x e to the x. And then I'm going to look for coefficients of just e to the x, so e to the x. So from the first term I get a 2a plus b. From the second I get minus 4b, so overall it's 2a minus 3b e to the x. And then this, I like to rewrite the right hand side at this point so that I have an x e to the x and an e to the x. So it's going to be 1 x e to the x plus 0 e to the x's. And now I can just kind of look and see, I know negative 3a should equal 1, and I know that 2a minus 3b should equal 0. So from the first equation, I know that a is negative 1/3. And then I know 2a minus 3b is 0. I just figured out what a is, so negative 2/3 minus 3b is 0. And then if I add 2/3 and divide by negative 3, I get b is negative 2/9. Okay, so now I know a and b, and the whole point was to find the particular solution there. So I've got these three things. So let's write y sub p. So we get this, just subbing for a and b. And then if we remember, the overall solution to this is going to be y sub c plus y sub p. And y sub c we found a long time ago. So it's c1 e to the negative 2x. Remember, that's the solution to the homogeneous version of the equation, differential equation. And so it's y sub c plus y sub p. And we're done. So I hope you found this helpful. Don't create too many extra constants when you're doing this method. And good luck.